In this video, I'm going to be dealing with simultaneous equations, and simultaneous equations are merely equations that have more than one unknown. So, for example, you might find that an equation has, for example, 3 unknowns, and you are told to find the value of each of them. So that an example would be if I'm having 3x minus y, which would be equals to 7, and x plus y giving me 5. So you find that in this example there are 2 unknowns, which I'm having x and I'm having y, but I'm supposed to find the value of each of them. So there are various methods of solving this. One of them is elimination. You have elimination method, and elimination we have another method called this. We use substitution method, and another one you can use matrix method. So we find that there are other methods, but mostly I'm going to be basing on these ones. So you can work out this, but still all of them have to give you the same answer. So out of that, let me start with this as my example, and therefore take this as my example 1. So if I'm to work out this, I'm going to be explaining. So you find out of that, I'm going to have, for example, 3x minus y equaling to 7, and then x plus y equals to 5. So by elimination, you find out of that we make one unknown to be equal to the other unknown in the other equation. That's why we label this and say that this is equation 1 and this is equation 2. So in case I choose this equation down here, I ensure that one unknown is equal to the other unknown of the same kind in different equation, and therefore if I'm to, I do that for the purpose of eliminating it in both equations. And therefore, for example, if you look at y and y in the other, they have equal coefficients, and therefore they can be easily eliminated. And therefore I'm going to come here and say that let me apply an appropriate sign in this case. And therefore, to eliminate y, negative y and y, positive y here is if I just add them, and therefore 3x plus x, I'll get 4x. Then negative y plus positive y would get 0, and then 7 plus 5, this would be equals to 12, and therefore I would have something that would be 4x, which would be equals to 12, and therefore divide by 4, and therefore x would be equals to 3 in this case. So having got that, I choose one of the equations to substitute. Then I say substitute into, for example, the most easy one. So out of that, my equation 2 is better. Of course, can easily be worked out. So out of that, I have the value of x. That means that x plus y would be equals to 5, and therefore x is 3, so 3 plus y, which would be equals to 5, and therefore y would be equals to 5 minus 3, of which y in this case would be equals to 2. So you find that this is how easy you can work out this, and it comes out very well. So let me try to use substitution method in this case. So if by substitution, still let's say will bring us to the same answer, but you find that it's a different kind of method, but it's very easy also. Now if you're having the same example and you're to work out this by substitution in this case, let's use substitution in this case. So out of that, you come here and say that you choose one of the equations. If this is equation 2, this is 1, of course. Now I choose this like an equation, for example 1 or 2. So that here I would prefer to choose 2, and therefore x plus y, which would be equals to 5. So I make one of them the subject, and therefore, for example, let me make x the subject. This would be x equals to 5 minus y. Having known that, then I come here and say I'm going to substitute this into equation 1. Therefore, substitute into 1. And therefore, I come here and say that 3x minus y will be equals to 7. And therefore, I said this would be 3 into, this would be 5 minus y minus y, which would be equals to 7. And therefore, this would be 15 minus 3y minus y, which would be equals to 7. And therefore, I have 15 minus 4y, which would be equals to 7. And therefore, negative 4y would be equals to 7 minus 15. And therefore, negative 4y would be equals to negative 8 in this case. And therefore, having known that, I come here and say divide by negative 4, divide by negative 4. Therefore, I get my y equals to 2. Then I decide to substitute, and therefore I say substitute into x equals to 5 minus y. Therefore, x would be equals to 5 minus 2, and x would be equals to 3. So you find that both methods work very well. Now, the third method of working on this is by matrix. So by matrix, there are some rules that we apply. Here you have to be conversant with multiplication mostly, and proper arrangement. Let's try it out. So to solve this by matrix, so this time we are using matrix method in this case. So if I out of that, if I come here, I say that I arrange this in terms of in a matrix form. And therefore, I'm going to have 3, 1. I'm having negative 1 and 1. I pick out the coefficients, and therefore, of course, if I multiply this in terms of x and y, I still get back this. So if I out of that, this would be equals to, I'm having 7, 5. Now, having arranged them like that, first thing I do, there are steps that are involved here. We have to get the determinant. After getting the determinant, you find that we have to, let's like get the adjunct. Adjunct. Having got the adjunct, we also have to get the inverse. And then afterwards, we are good to go. So out of that, the determinant of the original matrix. That means that if I'm to get the determinant, it would be equals to major diagonal. Okay, major diagonal, of which this will be in terms of product. Product will be in terms of product minus, actually both of them. If I remove this, minus minor diagonal, of which both of them they say exist as products. This one is a product, and this one also exists as a product. And therefore, I'm going to say that this would be equals to, and therefore my major diagonal would be this. And then this is my major, and this would be my minor diagonal in this case. And therefore, if I come here, major diagonal, I would get 3 times 1 minus, and therefore the minor diagonal I would have negative 1 times 1, and therefore this I would get 3 plus 1 in this case. So having got that, I say that this would be equals to 4. So this is my determinant. Having got this determinant, remember the next step is getting, now I'm going to get the adjunct, and therefore the adjunct in this case, if I have the adjunct, which would be equals to, the adjunct in this case would be, you change the major diagonal, the change position, that if I'm having this 1 would go in the place of 3, therefore I'd have 1 here, and 3 would go, let's say, to the other, replace the other, and therefore I'm having now the minor diagonal, they just change signs. Therefore I'm having, this would be 1, this would be negative 1, close this. Having got that, I'm going to come here now to get the inverse. So now the inverse formula would be equals to 1 over determinant into the adjunct, which would be in this case equals to 1 all over, of which I'm having the determinant, and then I multiply the adjunct, which would be 1, 1, negative 1, 3. And therefore, this would be equals to 1 out of 4, 1 out of 4. I'm having here, this would be negative 1 out of 4. I'm having, this would be 3 out of 4. And therefore, let's swallow this. Now, having got the inverse, our inverse is this one. Therefore, I'm going to come here and say that now to work out the general equation, I'm going to multiply this inverse on both sides. Therefore, I'm going to come here and say that if I'm having that, I choose the whole of this. Actually, the whole of this, I multiply on both sides. So if I'm having, I start with this, I'm having 1 out of 4, I'm having 1 out of 4, I'm having negative 1 out of 4, I'm having 3 out of 4. Bring the nation, which was 3, negative 1, 1, yes, and here 1, therefore, which would be equals to, I'm having, we're having here xy. Now also on the other side, I was having, you bring it also here, we don't need this, and this we already know it. We're having this like 1 out of 4, negative 1 out of 4. I'm having 1 out of 4 and 3 out of 4. Yes, and our answers were, we had 7 and 5. We're having 7, 5. So out of that, now we do the multiplication. I'm having 1 out of 4 times 3, we get 3 out of 4, plus 1 out of 4 times 1, which is going to be 1 out of 4. Now on this side, we have 1 out of 4 times negative 1, which would be negative 1 out of 4, plus 1 out of 4 times 1, which would be 1 out of 4. That one is done. So negative 1 out of 4 times 3, I would get negative 3 out of 4, plus I'm having 3 out of 4 times 1, of which I would get 3 out of 4. So I'm having again, so 1 out of 4, negative 1 out of 4 times, I would get 1 out of 4 plus 3 out of 4 times 1, which would be 3 out of 4. Now this is done. So, and I'm having this x, y, which would be equals to, I'm having here, so 1 out of 4 times 7, which would be 7 out of 4 plus 1 out of 4 times 5, which would be 5 out of 4. Now, negative 1 out of 4 times 7 would be negative 7 out of 4 plus 3 out of 4 times 5, which would be 15 out of 4. And this is also done. So out of that, I come down here. This is going to be, this is 4, and 4 divided by 4 would be 1. And therefore, this would be 0. And then this would be, I'm having here, so this would be 0. Because if I'm having 3 and 3, you get 0. So out of that, I'm having 0. So out of that, let's write this and this. I'm going to have 4, of which I'm going to get 1. Now, having done that, I'm going to say I'm having x, y, this case, which would be equals to, I'm having 7 plus 5, which would be 12. 12 divided by 4, which would be 3. And therefore, I'm having also negative 7 plus 10, which would be 8. 8 divided by 4, which would be 2. So out of that, this is what we call an identity matrix. And therefore, I'm going to come here and say that. Now multiply this with this. This is going to be 1 times x, which would be x, plus 0 times y, which would be 0. And therefore, 0 times x, which would be 0. Then 1 times y plus y. And therefore, this would be equals to 3, 2. Then afterwards, if we proceed with this, x, y would be equals to 3, 3, 2. And therefore, x equals to 3 and y equals to 2, of which they both bring out the actual answer. So you find that you can use any of the methods to bring out what you want depending on your choice. Now let's work out example 2, of which in this case I'm having 3x plus 5y equals to 11 and x minus y equals to 1. So by elimination, in this case, I'm going to make one unknown, let's say, equal in both equations. And therefore, I'm going to come here and say that if I'm to have, this is my equation 1 and this is my equation 2. And therefore, what I'm going to do here, I'm going to multiply something here, of which I'm going to multiply here 3 and I'm going to multiply here by 1. And therefore, I'm going to have 3x plus 5y equals to 11. And I'm having, this would be 3, this would be 3x minus 3y, which would be equals to 3. This would be equation 3 and this would be equation 4. And therefore, if I'm to work out this, you find that I have to just use appropriate sign to eliminate, for example, x. Now if I just subtract, I'm going to get, this would be 0, then 5y minus 3y, this would be 8y, and then 11 minus 3, this is equals to 8, then all over 8, and y would be equals to 1. Now let's substitute to get x, and then you say substitute into, for example, equation 1, and therefore 3x plus 5y would be equals to 11. Therefore 3x plus 5 is equals to 11. Therefore 3x would be equals to 11 minus 5, of which 3x would be equals to 6. So all over 3 x would be equals to 2 in this case. So you find that this is by elimination method. Now let's try working out the same equation using substitution method. If I'm out of that, if I have 3x plus 5y is equals to 11, and I'm having x minus y giving me 1. So if this is the same, this is equation 1, this is 2. And now to work out this by substitution, this time let's use substitution method. So by substitution, I'm going to choose one of the equations. So if let me choose equation 2. From equation 2, you find that x minus y is giving me a 1, and therefore let me make x the subject. Therefore x would be equals to 1 plus y. Having done that, now I say substitute into equation 1, and that means that I'm going to, my equation 1 states that 3x plus 5y would be equals to 11. Therefore if I'm to substitute in, I'm going to have 3 into 1 plus y plus 5y would be equals to 11, and therefore I'm going to have, this would be 3 plus 3y plus 5y would be equals to 11. Therefore this would be 3 plus 8y would be equals to 11. And therefore I'm going to have something that would be 3 this would be 8y would be equals to 11 minus 3, of which 8y would be equals to 8 all over 8 all over 8. So y would be equals to 1. Awesome. So having got that, let's substitute into this x, which would be equals to 1 plus y. And therefore I'm going to say that x would be equals to 1 plus, of which my y is 1, and therefore x would be equals to 2. And therefore you find out that the methods all bring out answers that are the same. So let's try to work out using matrix. So by matrix method, you find that I'm going to say that this would be 3 in matrix form, 3 1 5 negative 1 multiplied by the unknowns would be equals to the answers, which are 11 and 1. So if I'm to work out this, remember I have to get the determinant. So the determinant would be equals to, we'll have 3 times negative 1 minus, I'm going to have 5 times 1. Then this would be equals to, I'm going to have, this is going to be negative 3 minus 5, of which this would be equals to negative 8. So having got that, let's specify the adjunct. So the adjunct would be equals to, I'm going to have, this is going to be negative 1, and I'm going to have here, this would be 3, and here I'm going to have negative 5, and here I'm going to have negative 1. So having got that, then the inverse would be equals to 1 over that into the adjunct, and therefore this would be equals to 1 all over the determinant, which would be -8 into the adjunct, -1, -1, -5, and I'm having here a 3. Now, having done that, this would be equals to 1 all over 8, 5 all over 8. I'm having 1 all over 8, and I'm having -3 out of 8. So this would be it. So now we get this and multiply throughout. So if I'm having 1 out of 8, 5 out of 8, 1 out of 8, -3 out of 8, I'm having 3, 5, 1, -1, xy, which would be equals to 1 out of 8, 1 out of 8, 5 out of 8, -3 out of 8, and multiply by the answer. I don't need this. I'm having 11 and 1. So having done that, let's do the multiplication. So if 1 out of 8 times 3, this would be 3 out of 8. Then 5 out of 8 times 1, which would be plus 5 out of 8. 1 out of 8 times 5, which would be 5 out of 8. Plus 5 out of 8 times -1, which would be -5 out of 8. So 1 out of 8 times 3, which would be 3 out of 8. Plus -3 out of 8 times 1, which would be -3 out of 8. So 1 out of 8 times 5, which would be 5 out of 8. -3 out of 8 times 1, which would be plus 3 out of 8. So this one is done. We're having xy as our unknowns, which would be equals to, I'm having this would be 11 out of 8 plus 5 out of 8, and this would be 11 out of 8 plus -3 out of 8. Having worked out, now let's find out. So if this would be 8 out of 8, which would give us 1, and then this would be a 0, and then this would be a 0, and this would be a 1. We're having xy, which would be equals to, I'm having this is, I'm having here, this would be 16 divided by 8, 2, and then this minus this would have 8, which would give us a 1. Having got that, now let's work out for the final answer. We find that this would be 1 times x, which would be give us x, and then 0 times y, which would give us a 0, and then down here we would have 0 times x, which would give us a 0, then 1 would have y, and then this would be equals to 2, 1. Therefore, in this case, x would be equals to 2 and y would be equals to 1. So you find that all the 3 methods give you correct answers. So depending on your choice, you can choose any to be using. Let's work out this example 3. So I'm going to preferably use substitution to solve this. Out of that, if I'm to simplify this, this is like having 2 squared, I'm having y outside, plus 2 to the power x equals to 12. And therefore, for the down one, I'm going to have 3 into 2 to the power x minus, this is 2 into 2 power 2y is equals to 16. So the down one is already simplified, and actually if I label them, this is 1, this is equation 2. So having got that, I'm going to come here and say that since down here, if you look, I'm having 2y, and here I can make it also 2 to the power 2y. Therefore, I'm going to come here and say that I'm going to have, this is going to be 2 to the power 2y plus 2x would be equals to 12, of which this would be equation 1. And then I'm having, this is 3, but I have to arrange them accordingly. Therefore, I'm going to have 2 to power 2y also, and it is negative in this case, and then plus we're having 3 power 2x, which would be equals to 16. Having all that, then I say let 2 to power 2y be m, and 2 to power x be n, and they all work. And therefore, if I am to represent these in both equations, I'm going to come here and say that 2 to power 2y is m, plus I'm having this 2 to power x, which is n, will be equals to 12. And then in the second equation, it would be negative 2m, also negative 2m, plus I'm having 3n would be equals to 16. Having done that, now I'm free to work out simultaneously. So as I said, you can use any of the methods, but I would prefer using substitution because it's at least cheaper. So out of that, I'm going to come here and say that this would be, now if I'm to make m in both equations equal, I'd come here and say I multiply this by 2 and this by 1. Therefore, I come here, this would be 2m plus 2n would be equals to 24. And then this would be negative 2m plus 3n would be equals to 16. And therefore, if I'm to apply an appropriate sign, this would be addition. Therefore, if I add this, I'm going to get 0, but this would be 5n, which would be equals to now 24 plus 16. Here I'm going to have, this would be 10, and here I'm going to have, this would be 4. So all over 5, and here I'm going to get n, giving me something like 8. Now, having got that, I substitute now and say that for m in this case, I know that remember we used original equations, so m plus n was giving me 12. Therefore, this would be m plus 8, which would be equals to 12, and therefore m would be equals to 12 minus 8. Therefore, m would be equals to, this would be 4. Now, having got that, remember you're not yet completely done. So we're still working and continuing to work out, because if we look here, we have n and m having what they are presenting. And therefore, I come here and try to get those actual values. We want to get x and y. And therefore, if 2 to the power 2y is equals to m, 2 to the power 2y is equals to m, but m is equals to 4. Therefore, 2 to the power 2y equals to 4, and therefore 2 to the power 2y equals to 2 to the power 2. Same powers, that means that 2y would be equals to 2, then y would be equals to 1. Now, at the same time, if we are to get the value of x, remember, n is equals to 2x, and n is equals to 8. That means that this is equals to 2 to the power x. This is 2 to the power 3 would be equals to 2 to the power x, same basis, so powers are equating, then you find this would be equals to x. So you find that would be the value of x. Thank you for watching. Please don't forget to subscribe for anything that drops out. So thank you once again.